Hi everyone, welcome back to my Number Sense series. This is going to be our last video about geometry, and this time we're doing 3D geometry with spheres and cylinders. Now, like our previous video, with spheres and cylinders, there are two things we're concerned about for each one. The first thing is surface area, and the second thing is volume. Now, a sphere is like the 3D version of a circle, right? A circle is defined as the set of all points that are equally close to the center point. And the sphere is the same thing, just in 3 dimensions. Now, instead of a diameter, what you see drawn in a dotted line here is kind of like the 3D version of a diameter. This is called a great circle, the largest circle that you can draw in a sphere. And I drew it here just to help you realize it is a sphere and not a circle, right? To make it look more 3D, just like this. All right, so we want to know two things about the sphere. The first thing is its surface area, and the second thing is its volume. Now, sadly, both of these things are too difficult to derive in this video, as it would require some more complex ideas that I don't think we can really do just yet. So I'm just going to tell you the formulas for each of these, and hopefully you can get a little bit of practice with applying them. So for surface area, we are once again going to use our friend pi, just like we had to use for circles. Recall that pi is approximately 3.14. The surface area of a sphere with radius r is 4 pi r squared. In other words, it's 4 times r squared times pi. Now, maybe if you are very clever, you can see how the surface area actually does relate to the volume, because the volume is going to be 4/3 pi r cubed. Now, Number Sense likes to test you on surface area much more than volume, but I think it's good to learn volume just in case, and also just because knowing the volume of a sphere is a very valuable thing to know. So the volume is going to be 4/3 times pi times r cubed. You can see how surface area is a 2D measurement, right? Area, which is why you have r squared, and volume is a 3D measurement, like how much water can you fit in the sphere, and that's why we have r cubed. Just a little bit of intuition there. Now, a cylinder is actually kind of like a prism. Previously, we did rectangular prisms, and there we learned that the formula for the volume of a rectangular prism is to multiply all the dimensions. And it's kind of like this for a cylinder, because the volume of a cylinder is simply going to be the area of the base times the height. Now, a cylinder we define by two variables, r and h, so the radius of the base and its height. And also, another note, I'll tell you that note after we write the formula. So the base of the cylinder is going to be a circle. So the area of the circle is pi r squared. Then pi r squared times the height h is just going to be pi r squared h. Right, now for the note. In contests, you're going to see the words right circular cylinder very often, or maybe right cylinder. Don't worry about this. Right means that the cylinder is, upright, it's not slanted, but actually that doesn't actually, change the volume formula, but don't worry about it. Right just means it's upright, and circular just means that the bases are circles and not ellipses or anything. So Number Sense just puts that there to confirm no one can be like, technically, and then try to dispute the problem. Right circular, don't worry about it. That's just the kind of cylinder you see when you search up cylinder. Now, the surface area is a little bit more interesting because we have to sum two different shapes. We have two circles that are on the top and the bottom, but also we have this thing that wraps around the entire cylinder. And in order to calculate the surface area of the thing that wraps around the entire cylinder, because we know how to do the bases, it's just circles, which is 2 pi r squared. In order to do this wraparound thing, we have to actually make it 2D. Imagine that you have a soda can, right? A soda can maybe has a wrapper on it. Imagine taking that wrapper off. I'm sure some of you have done this with maybe your water bottles. Take that wrapper off and lay it flat on a table, right? Unroll it. What does it make? It makes a rectangle. And the dimensions of that rectangle are such that the height is actually equal to the height of the cylinder. And you should be able to imagine this, because imagine if you unroll it about this, it'll unroll like this, and it'll be a rectangle where the h is preserved, the height is the same. But what's the length of the rectangle? We might imagine a piece of paper, because if we want to imagine a paper wrapping around a cylinder, it would look like this, right? We would fold the paper like this to make a cylinder. So the length of this rectangle becomes the circumference of the circle, as you can see, right? So when we unfold it, the length of the rectangle will be equal to the circumference of the circle, which is 2 pi r. And so that means the area of this rectangle, which is like the wrapper, will be 2 pi rh. So our total surface area will be 2 pi r squared plus 2 pi rh. So here are our two formulas. 2 pi r squared plus 2 pi rh for a cylinder. And really, if you understand where this formula comes from, you don't actually have to memorize, okay, r is this, h is this. You can kind of think of it in your head just. And the volume of a cylinder is going to be base times height, or in other words, pi r squared h. So now that we know these, let's get some practice in. Now, once again, number sense likes to ask you about surface area a lot for spheres, which is why both of these problems are surface area. The first one is they give you surface area and they want diameter, which is basically radius, kind of. And the second problem is they give you radius and they want surface area. So you can see the two kind of problems that they're going to throw at you, but they're very similar. So if they give you that the surface area is 225 pi, well, if we want diameter, we need to solve for radius first. So we should use the formula for surface area because that has radius in it, equals 4 pi r squared. Now, of course, we want to isolate r squared, so we should divide both sides by pi to get rid of that first. Always do that. Then we have to divide both sides by 4. Or we can square root both sides and then divide by the square root of 4. Either way, I'll show both ways. If we divide by 4 on both sides, we get 225 over 4 equals r squared. So r, which is positive, equals 15 over 2. If we take the square root of both sides first, we get 15 equals 2r, and we get r equals 15 over 2, just like that. But once again, we're not solving for r, so don't box this. We're not solving for r, we're solving for d. And so diameter equals 2 times the radius. 2 times 15 over 2 is 15. And you can also tell, because in contest, if you got this problem and you're thinking that you're going to write down 15 over 2, you should look there at the answer blank and see that they don't say fraction. If it was 15 over 2, they would probably say fraction. So if you're about to write 15 over 2 and it doesn't say that, you probably messed up. Okay, so the answer is 15. But we can also go the other way, where they give you radius and they want surface area. And this is just a straight application of the formula, actually, so let's do it. 4 pi r squared. But r is 5 over the square root of pi. And maybe you think that this is a very weird number that they chose, 5 over the square root of pi, and it is weird, but they only did it to make these pi's cancel out, as you'll see. Because 5 over the square root of pi squared is 5 squared over the square root of pi squared. Right? And this is going to be equal to 4 pi times 25 over pi. So now we can see that these pi's will cancel out, and it's just 4 times 25, which we should know is equal to 100. So that is spheres, and once again, it's mainly about surface area, so it's just getting familiar with this one formula mostly, and just applying it, doing a little bit of manipulation in your head if necessary. Now, cylinders are a little bit more complicated, especially for surface area, because you're going to have to do more multiplication and then also some addition, but if you are used to it, it's going to be very easy still. The height of a right circular cylinder with radius 3 and volume 144 pi is. So here they want you to work backwards using the volume formula. So let's do that. We have pi r squared h, once again the volume formula, equals 144 pi. We know r and we want h, so let's plug in r. So we have r squared, 3 squared is going to be 9, so we have 9 pi h equals 144 pi. So we divide both sides by pi, then it's 9h equals 144, so h equals 16. And that's it. Once again, these problems for geometry are all pretty similar. It's either use the formula and work backwards or just compute the formula. There's not too much creativity that number sense is going to put in these problems because they know you have to do them under time pressure. Now, last problem. Once again, this is going to be the hardest, but it's only hard because of how much computation you have to do. If you're practiced with this computation, it's just going to be a little bit of time waste, not too bad. So they want the surface area of a right circular cylinder with radius 7 and height of 10. So even if you don't have the formula memorized, I hope that you should be able to kind of think about how this works during the contest. Because to compute the surface area, you need to add the two bases. So each base is going to be pi r squared. And if r is 7, each base is 49 pi. So combined, the two bases are going to be 98 pi. Plus this wrapper thingy, right? The wrapper is actually a rectangle, right? As we remember, if we kind of unfold this wrapper to make it 2D, it becomes a rectangle. Now the height of that rectangle is going to be the height of the cylinder, which is 10. So it's 10 times. Now the length of the wrapper is going to be the diameter of a circle, because the wrapper was originally wrapped around the circle, right? So the length of the wrapper is the diameter. The diameter is 2 pi r. 2 times pi times 7 is 14 pi. So it's going to be 140 pi. And so our total surface area will be 98 pi plus 140 pi, which is equal to 238 times pi. 238 pi, that's what you would write. So this is our last geometry video on spheres and cylinders, and you can see, honestly, it's not much different from the other ones, because all you have to memorize are a few key formulas, 2 formulas for each shape, and then the problems are really just about applying the formulas either forwards or backwards. So once you get some practice with these, the formulas will naturally ingrain themselves into your memory, and it's just going to be, plug and chug, write the answer, move on. So I hope this video was really helpful for you guys. Thank you guys so much for watching, and I'll see you next time.